Let's do let's go over GABA really quickly. Uh, First of all, just to review, we have different receptors on a neuron. So here we have our presynaptic neuron. This is the axon terminal. That's going to be sending a neurotransmitter. This is the receiving dendrite of a postsynaptic, because this is our synapse. There's two types of receptors. You have voltage-gated receptors and ligand-gated receptors. If it opens from something binding to it, it's a ligand-gated. And those are going to be located here on the dendrite, because this is where neurotransmitters are going to be binding to it. If it opens due to a voltage, like -55, +40, that's going to be located down here on the axon. So these are going to be voltage gated. You also have one voltage gated down here at the very end on the axon terminal. So you would also have them here on the axon terminal of this one. And this, of course, is going to be for calcium. All right, so you have neurotransmitters that are excitatory. They're going to get the neuron up to threshold so it fires. And then you have neurotransmitters that are inhibitory. It's going to lower the resting potential, so it takes a little bit more to fire. And GABA is an inhibitory one. So let's go through a excitatory first. So let's say you have an excitatory neurotransmitter like epinephrine. You also have glutamate, things like acetylcholine, a little bit, but so let's say like epinephrine, that's like adrenaline. We know that's going to be excitatory, right? So that's going to get released into the synapse, and it's going to bind to a ligand-gated sodium channel. So when this opens, only sodium can come in, which is positively charged. So this is a ligand-gated sodium channel. And the ligand is the neurotransmitter. It never enters the postsynaptic cell. It binds to the receptor, opens the channel, and then gets recycled back into the presynaptic neuron. So when this opens, sodium comes in. It's going to raise the resting potential. So that resting potential is going to be higher than -70. So we call that an EPSP, which stands for excitatory postsynaptic potential. So it sits a little bit higher, so it reaches threshold faster for this nerve to fire, to send an action potential. GABA is an inhibitory neurotransmitter. So you have GABA in the presynaptic cell. And when that gets released, it's going to come over here. I crisscrossed them a little bit, ignore that. And it binds to a ligand-gated chloride channel. Chloride has a negative charge, so it's going to make that membrane more negative. So it's going to be harder to reach threshold. So again, GABA never enters this cell. It binds to the receptor and opens the channel. So and only chloride can go through this channel. It's a ligand-gated chloride channel. So when that opens, negative ions come in, negative chloride ions, which is going to lower the resting potential below -70, like maybe we'll say -80. So it takes longer to reach threshold, and it takes more stimuli to reach threshold to fire. Because remember, in order for it to fire, it has to reach -55. Because at -55, the voltage-gated sodium channels open. Over here, we have voltage-gated sodium channels, voltage-gated potassium channels, and sodium-potassium pumps that reset the neuron after the action potential has been sent. Down here at the end, this is a voltage-gated calcium channel that opens at +40 for calcium to come in bind to the neurotransmitter and help it be released. So that's what happened here. The calcium, it got to positive 40. Calcium came in, bound to the neurotransmitters, and helped them be released into the synapse. Hope that helps.